So in this section, we will learn regarding quality of service. Okay. And this quality of service, this is a additional set of network technology that is added. Okay. So we can note here the additional sets of network technologies. Okay. These are used for managing your traffic and prioritizes application to ensure the network performance. Okay. So we have all the management of our traffic, also the prioritization. Now, in this particular section, I will cover in detail regarding what are the common network uses that we have. Okay. For the quality of service and how to control the traffic. Then I will discuss regarding what are the QoS models. Then we will learn detail regarding quality of service. So there are multiple components of this quality of service. So the first one is known as classification. Once you have classified, then what we do is these classified data or the traffic will be marked. Okay. So then we have traffic marking. So this QoS itself is divided into multiple subcomponents. Okay. So we have classification, marking, then we have policing. So these are the components. Policing, or this is also known as shaping. Okay. Then I will cover in detail regarding something called as the algorithm behind this, that is called as token bucket algorithm. Post that, we'll learn other components. The first one is called as queuing. Then we have scheduling. And shaping. So the same thing is named like this. So the classification, traffic marking and policing, we call them as queuing, scheduling and shaping. Then last, we will see the difference between what is policing and shaping. Okay. The difference between policer and shaper. So we will differentiate what are the key points in polisher and what are key points in shaper. Okay. Now coming to the first point that I need to take up in this particular section, that is what are the common network uses. Okay. So common network uses of quality of service. So the first point comes to the quality of service when it is applied to network uses is whenever we have network congestion. Now, network congestion occurs when a network node or link is carrying more data than it can handle. Okay. So let's say you have network from, let's say, from A to B, but this is a 1G link, but let's say we are trying to send more than 1G link. We are sending, let's say, 1.5G link, 5G traffic. Then how this will be congestion occurring, like which should be sent here and which should be dropped. So in these cases, we can apply this quality of service in case of network congestion. And what are the effects of this? This effect include the queuing delay. So these delay happening in the queue of the polisher side, where your traffic is incoming to the port. Okay, so there it will be queued. So there will be packet loss, and it will block the new connection that is incoming, because somehow it has to manage only 1G traffic that will be allowed in the network side. So the first point was network congestion. The second point, it is applied where we have more of packet losses. Okay. Now this packet loss happen when network link becomes congested and routers and switches start dropping packets. So similar condition, after the network congestion has happened, your network link, okay, will start dropping the traffic or the packets. Now this packet loss increases like latency due to additional time needed for the retransmission. Now, since it is trying to drop, but somehow we have made sure that this will be retransmitted, okay, but this will increase the latency. Now, this also include the issues like breaking up the voice communication in, in cases where we are trying to send our voice type of traffic. These packets never should be dropped because we will not be able to decode the data what it was transmitted. So there should be some prioritization happening to the voice traffic or video traffic, because even if it is retransmitted, you will not be able to make out due to the increase in the latency. Then we have this loss of data generates a negative user experience because of these packet losses and network congestion. The next point is called as that where it is used wherever we have jittering. Okay. Now this jitter is defined as a variation in the delay of received packet. Okay. So let's say it was sent in time interval T1, but I am receiving at this location B at time 2, T2. So there is a slight delay happening. Okay. So it is T1 plus delta T. So this delta T is the variation in the delay of the received packet. Okay. This all is happening because the network congestion. Because of this, the timing drift changes and the route also might change. So if it is a different part of network also, if it is connected something like this, so it might take a different route for retransmission just to avoid this network congestion. Now, too much of delay, once this increase in this jitter happens, okay, or too much of delay, because of this, there might be, it will affect your voice traffic that is being transmitted. So audio problem will occur when it is received on the receiver end. So it is not just it will affect the voice communication, but also in the video type of traffic also it will affect. Because when it is retransmitted, it might not be the same pixel that is being retransmitted. By the time the frame would have changed here in the side B. Once we have discussed the where it is used in jitter, then we have something called as latency. Now, latency is the time a packet takes to travel from its source to destination. Okay. So variation in the time is called as jitter. So latency is the total time that it takes from when it is sent from source and it is received at the destination. So this is actually measured in the round trip time. Round trip time. Okay. So again, we have here under the latency. So this is basically it drives the responsiveness of the network, that how fast the responsive the network is. Okay, from A to B if I am transmitting, how I am getting the acknowledgement. So this is the round trip. Okay, again your message comes back. So the bigger is the round trip time. That means the connection is very slow. Okay, because it is taking so much time just to get the acknowledgement from the receiver end. That means your network is quite slow. Okay. Now, because of this latency, the performance will also go down if it is taking more round trip time. So performance is directly related to this latency as well as jitter. Okay. And under this performance sector, we can also have this. We can directly tell that latency is driving the throughput. Next is the wherever we have this bandwidth scarcity. Okay. Now this bandwidth is the capacity that a network communication link is having to transmit the maximum amount of data from your location or site A to site B or from source to destination. And it's not just about sending amount of traffic, but in the given interval of time. Let's say it is bandwidth, let's say define as, for example, I'm taking 1 Gbps. That means 1G traffic is sent per second. Okay. So if all the ports that is connected in this link is 1G or 1 gigabit per second, that means it is able to transmit at this rate. Let me just take new slide. Now the second point that it was in the content was, how do we control this? Okay. So whatever problem we had here in the network use of quality of service, you have network congestion, packet losses, jitter, latency, and performance, and scarcity of bandwidth. So how do we utilize it in a efficient manner and make sure there is no loss of latency or increase in jitter or packet losses or better use of the bandwidth? Then how to control this is my next topic. So the answer for this is quality of service. or in short, it is called as QoS. Now, how this QoS is defined? Okay, QoS refers to the capability of network. Okay, this is nothing but the capability of network to provide better service to selected network traffic over various technology. Okay. Now we can note down here that the primary goal, okay. So the primary goal of QoS is to provide the prioritized traffic for a dedicated bandwidth. Okay. Prioritize traffic for dedicated bandwidth. Now here it also includes controlled jitter and latency. And unlike previously, we will have improved loss characteristics. Now this QoS enables us to provide better service in to a certain flows. Okay. So this is either done by raising the priority of flow or limiting the priority of another flow. So what happens is when I'm telling we prioritize certain flow, let's say multiple types of traffic is coming. Okay. There is a voice traffic, there is a video traffic, and we have data traffic. Now we can prioritize this voice traffic and video traffic because if any packet is lost, it might not mean the same communication that is being transmitted on the receiver end. Okay, so we can change the flow of this voice and video, and we can also change the flow of data. So we can set priority for different flow of data, and we can set here. So this is my first part of video. In the next part of video, we will start with different types of QoS models. Okay. So the second part of video will contain the QoS models and little more detail regarding this quality of service. So different components of quality of service. So thank you. Let's continue in the second video.